Hi Marats, welcome to the description of our ecological project. We are going to deal with forest fires and their possible connection to arson crime. Besides, we are going to learn what is GDP per capita and how can it be used in order to categorize and analyze countries of the world. From the math perspective, we are going to use set operations and Venn diagrams together with the knowledge of quantiles to categorize world countries. Python-wise, you will be exposed to pandas module, a powerful data science tool for working with data which are organized in tables, which you can also see as an alternative to working with Excel. There is a lot to cover in this project, but first I need to get you excited about it, right? So, try to imagine that you are an UN ambassador for climate change. Exactly, it's pretty hard position, because you have to deal with powerful states, powerful companies, which keep ignoring you so that you cannot do much about climate change directly. Therefore, you are trying to find an alternative way to contribute to combating climate change, which is also, by the way, responsible for extreme weather patterns, such as more intense and deadly forest fires. And at that exact moment, you got an idea. Some of those fires have to be caused deliberately by arsonists. At the same time, you know that governments love to fight against crime. So if only you could identify countries which are potentially soft on arson crime, convince their governments to make legal adjustments, which are cheap and actually exist in other countries, you could actually save lots of CO2 emissions, lives and money. And that is our objective. Can we, from freely available data on the internet, identify countries which could have problems with arson crime? I think it's pretty clear by now that this is not an exercise, but an open-ended project which we can constantly improve and develop. So the particular question at hand is, based on the presented tabular data for most countries in the world, can you identify those potentially soft on arson crime? As always, we are going to start with importing modules. As I promised, we are going to work with pandas, which is typically imported as PD. Second module is API, which enables directly access data from the World Bank. Then I have some plotting module, pyplot, and specific methods to visualize Venn diagrams, Venn2 and Venn3. Then we are going to load the precompiled data, which is done directly by using pandas module and reading CSV file, which is called data_fires.csv. And then we are set how are we going to index our table. That means referring to our rows according to ISO code, 3-letter code for each country. Then we are going to inspect our table, count how many data we actually have. Then I will comment what are the sources for the data, how I get it, how I analyzed it, and how you can check the sources yourself. And after that, we would like to compare the countries relative to each other. The absolute sizes of the countries differ very much, so we are going to compare fractions of the burned forest and add it as an additional column to our table, which will appear here. And then I am going to introduce you to the master logic of our project. In the end, we want to say the following. Give me the countries which have decent rains, temperature is not rising too much, but there are still lots of fires. And maybe those are because of arson. And this kind of logic, give me countries and, adding the condition, will be realized by intersecting sets, which we are going to create. And since we are also cross-checking, if the forest fires cannot be justified by increase of the temperature or low precipitations, we have in our table also temperature-related and precipitation-related data. We will test our logic on our European countries first. And then the question is, how are we going to compare them in relative terms? And that will be done using so-called quantiles. Quantile can be viewed as a threshold value which splits the group of values into two parts. One part will have the values below this threshold, and the second part will have all the values above this threshold. That's how we can identify certain percentage of countries with high burned ratio or fraction of the forest. So we are going to first select European countries and then apply this quantile method on the fraction of the burned forest to identify 30% of countries with highest burned fraction of the forests. And we can find out what that number actually is, even without knowing how much burned forest is a lot. And then we are going to select those countries by the condition that the fraction burned needs to be greater than our limit. And then we are going to create a set of countries, the ISO codes, for our candidates. Then we need to create additional set with the countries which do not experience too large temperature change. And the third last set will be the countries which do not have too low precipitations. Then we can practice our intersection logic, first intersect two sets and finally intersect three sets together in order to get the final candidates of the countries with potential arson problems. And after that, we can also visualize the relationship between our sets, how they share their members in so-called Venn diagram. We have countries with high burnt area, low temperature change, and not very low precipitations. Then comes the question in the second part of the project, how to compare all the countries of the world. It's still unjust because they are so vastly different, so we need some other measure how to categorize them first. And we are going to pick a developmental measures, which is GDP per capita. GDP, gross domestic product, is what country produces in terms of value of money. And if we split it between all the people, that's how much money basically they have available to spend over the year. And this data is available through the World Bank API, so I can directly access the data by the name of the dataset. Again, the countries are identified conveniently by their ISO codes, so I can merge the new data on my original data frame. And then I will rename the column and check the head, and we will get new column called GDP per capita in dollars. Then we will play with the GDP values themselves. And now comes the categorization. Some people might still be thinking that the world is divided between developed and developing one. That's not exactly true, and Hans Rosling and his Gapminder project teaches us that this is a myth from 50 years ago. And there are actually 4 levels of countries divided by the dollars per day, and the division levels are $2, $8, and $32 available for every person per day. So we are going to categorize those countries to level 4, 3, 2, and 1. And again, add it to our data frame, we will get final column with the GDP level here. We again will discard some missing data because even the World Bank data are incomplete. And then we are going to count the values for each level and we will see the distribution of countries. And truly, the division works that we have substantial amount of countries at each level. And then we can repeat the same logic as for the Europe, but now for level 1, level 2, level 3, and level 4 countries separately. That's basically the rest of the project. And then we will arrive to some final conclusions and some more questions for your thought. I hope I spurred some curiosity, and I hope you will try to solve this project by yourself. If not, you can find the solved notebook in the link in the description of the video. Also, you can find there the task or the webpage which contains many more exercises. Enjoy and have fun. Cheers!